Welcome back to The Explainer. I'm your host, and today I'll be acting as your senior systems architect. We're diving into a true Silicon Valley-style Cambridge exam hackathon. We're looking at the Cambridge AS and A-level accounting syllabus, specifically Topic 9706, and we're going to treat it like a highly misunderstood, incredibly complex software mainframe that just needs a little bit of debugging. We're talking about errors affecting the trial balance and errors not affecting the trial balance. You know, examiners report that this is one of the most crashed, bug-ridden areas for students, but by the end of this session, you're going to be able to compile the absolute perfect, high-scoring response algorithm.
Okay, let's run our boot sequence. First up, the target mainframe. Second, debugging system errors. Third, the procedural framework. Fourth, executing the analysis. And finally, examiner's security warnings. Let's dive right in.
Section 1. The target mainframe, defining core system requirements.
So to successfully hack this mainframe, you need to know that the Cambridge assessment system targets 3 distinct cognitive domains. Think of these as 3 separate firewalls you've got to clear. Firewall 1 is knowledge and understanding. Basically, do you know the core accounting principles? Firewall 2 is analysis. Can you take the given data and actually break it down? And then there's the final, and honestly the toughest firewall, evaluation. Can you make fully justified recommendations? Successful candidates absolutely must clear all 3 of these firewalls to pass the system checks and secure those maximum marks.
Moving into Section 2, debugging system errors. Identifying the bugs.
Right, so let's look at the bugs themselves. On one side, we have errors affecting the trial balance. These are your uneven errors, mathematical mistakes or single-sided entries that literally throw the whole system completely out of balance. On the other side, we have errors not affecting the trial balance. These are the sneaky logic errors. This means leaving an entry out entirely, which is an omission, or putting it in the wrong person's account, a commission error, or maybe using the completely wrong class of account altogether, known as an error of principle. Now, the trial balance might actually look totally fine on the surface, but the underlying code is deeply flawed. Multi-stage analysis right here is exactly where so many candidates experience a critical system failure. They might identify the bug, sure, but they fail to track how it actually affects the profit calculation further down the line. Now, what's really interesting about this is something straight from the top. According to the principal examiner reports, candidates referencing cross-topic connections achieve significantly higher marks. Guys, this is your ultimate cheat code. In our hackathon terms, if you can link a trial balance bug to, say, depreciation, or maybe to control accounts, you are proving to the system that you understand the entire architecture, not just one little localized script.
Which brings us to Section 3, the procedural framework, the method mark strategy.
So here is the critical algorithmic sequence you need for higher-order, multi-part problem solving. Step 1. Deconstruct. You identify the given info and break it down into logical steps. Step 2. Solve systematically. Always checking for reasonableness as you go. Step 3. Evaluate. This is where you make those justified recommendations. Let's look at 2 hypothetical junior developers on our team, Dev Alex and Dev Sam. Now, Dev Alex is fantastic at raw data inputs but completely skips step 1. That causes massive memory leaks because they just didn't deconstruct the scenario first. Then we have Dev Sam. Sam loves running logical loops in step 2 but totally fails the syntax precision rules of step 3 by forgetting to evaluate. You absolutely must run all 3 steps. And remember, this framework is specifically designed to secure method marks. Even if your final balance output fails and the numbers just don't match, showing this clear logical process will still rack up major points.
There's a really strict procedural loop required to actually develop professional skills here. You have to identify key elements, apply relevant principles, execute analysis with clear working, verify your results, and present it all in an appropriate format. Skipping any one of these steps is literally like writing sloppy code that hasn't been beta tested. Look, if you don't execute your analysis with very clear workings, the examiner, who is basically your senior code reviewer, cannot grant you those method marks. Clear workings are your code comments. They tell the examiner exactly what logic you use to get there.
Section 4. Executing the analysis. Running the trend extraction. But wait, before we push this final patch to the live server to secure maximum marks, I need you to optimize your system feed. Subscribe to Ace the Exams at the handle @AceTheExams right now, and turn on all notifications for our weekly system updates. Let's keep your brain software totally up to date. Okay, patch compiled, let's deploy the analytical framework.
You see, top candidates don't just stare blankly at the data. They actively extract strings of data to run their analysis.
Extraction means pulling the raw numbers out from chaotic source texts. Interpretation is finding the relationships, like how exactly does an error of principal in a fixed asset account impact the suspense account? And conclusions, well, that's where you draw evidence-based findings. If you ever encounter a logic error mid-argument in your essay, you instantly deploy the PEL syntax structure, point, evidence, explanation, link, to debug and upgrade your paragraph right there on the spot.
Building this into the absolute highest level of assessment requires evaluating the quality of your evidence. This isn't just about stating what happened. It requires identifying limitations, the assumptions made, alternative interpretations, and their overall effect on your conclusions. The top-scoring developers, the students actually getting the A-stars, they question the assumptions in the prompt. They actively consider alternatives so they can justify their decisions with hard, undeniable evidence. They don't just fix the code, they explicitly explain why their fix is the absolute most optimal solution.
Section 5. Examiner's Security Warnings. The Firewall Blocks.
Pay attention, because here are the top 3 fatal syntax errors where students leak easy marks straight from official examiner data. Number 1, forgetting to include proper format. Seriously, if the system asks for a journal entry, do not give it a T account. Number 2, forgetting to check presentation. Messy code gets rejected, simple as that. And number 3, answers are not specific to the context given.
Let me emphasize this with a critical warning. Generic answers absolutely guarantee a rejected patch. If the prompt is specifically about a manufacturing business that just bought new machinery, and you just give a generic textbook definition of an error of principle without ever mentioning the machinery or the manufacturing context, you lose the points. You must link your answers to the given scenario context. Context is literally the runtime environment for your exam algorithm.
To help you avoid these dreaded memory leaks, here is a really quick memory hack. You can compile and store key terms super efficiently in your own memory banks by creating a mnemonic for errors affecting and not affecting the trial balance. For example, for errors not affecting the trial balance, remember the acronym CCOOP. That's Commission, Compensating, Original Entry, Omission, Principal. Just find a syntax that works for your brain's hard drive and lock it in for good.
Which brings us to our final system check. If a really complex error crashes your trial balance, how will you deploy the Deconstruct, Solve, Evaluate framework to extract maximum method marks? I want you to really think about that. I challenge you to apply this cheat sheet architecture to your very next past paper. Treat it like a high-stakes hackathon. But before you log off today, make absolutely sure you subscribe to Ace the Exams at the handle @AceTheExams. Click that bell to never miss a critical update and leave a comment below with your subject and level so we know exactly what system to debug next. Happy coding, and I'll see you in the next explainer.